Civil engineer. The civil engineer designs and oversees the construction of the physical structures that hold modern society together. Roads, bridges, dams, tunnels, airports and water systems all fall under their responsibility. This is one of the oldest engineering fields in existence, with roots stretching back thousands of years to the people who built ancient roads, aqueducts and irrigation canals. In fact, for most of history, civil engineering simply meant any engineering that was not military. A civil engineer must constantly balance three competing pressures: safety, cost, and durability. A bridge has to be strong enough to never fail, cheap enough to actually get built, and long-lasting enough to serve for decades without constant repair. Much of the real work happens long before any concrete is poured, through careful planning, soil testing, load calculations, and computer modeling. When a structure does fail, whether it is a collapsed bridge or a cracked dam, the cause is almost always traced back to a civil engineering decision. That heavy responsibility is why the field carries some of the strictest safety standards and licensing requirements of any profession. Today, civil engineers are also at the center of huge modern challenges, designing infrastructure that can survive earthquakes, floods, and the growing pressures of climate change. Aerospace engineer. Aerospace engineers design aircraft, spacecraft, satellites, and missiles, working on machines that operate in some of the most extreme conditions imaginable. The field splits broadly into two areas. Aeronautical engineering deals with flight inside the Earth's atmosphere, like airplanes and helicopters, while astronautical engineering deals with travel beyond it, like rockets and spacecraft. This is widely regarded as one of the most demanding engineering disciplines because the vehicles must survive enormous speeds, crushing pressures, freezing and scorching temperatures, and violent forces, often all within the same mission. The field advanced at a staggering pace during the 20th century, driven first by military aviation in 2 world wars, and then by the Cold War space race, which pushed humanity from simple propeller planes to landing on the moon in just a few decades. Aerospace engineers work with cutting-edge materials and rely on extensive testing, simulation, and enormous safety margins, because even a tiny error can be catastrophic and impossible to fix once a vehicle is in the air or in space. Today, the field is being reshaped again by private space companies, reusable rockets, and a new race to send humans deeper into space than ever before. Chemical engineer. Chemical engineers turn raw materials into useful products through controlled chemical processes. They are the people behind the large-scale production of fuels, plastics, medicines, fertilizers, food products, and even cleaning supplies. There is an important difference between a chemist and a chemical engineer. A chemist might discover a useful reaction in a small glass beaker, but a chemical engineer figures out how to safely run that same reaction at the scale of an entire factory, producing tons of product every day without waste or danger. The profession became essential during the rapid growth of the oil refining and pharmaceutical industries in the 20th century, when the world suddenly needed enormous quantities of refined chemicals and reliable medicines. A large part of the job involves designing systems that handle extreme heat, high pressure, and powerful reactions in a controlled and predictable way. They also focus heavily on efficiency, since wasting even a small percentage of material at industrial scale can mean millions in losses and serious environmental harm. Increasingly, chemical engineers are also working on cleaner processes, sustainable materials, and ways to reduce the pollution that older industrial methods created. Electrical engineer. Electrical engineers focus on the generation, transmission, and use of electricity and the systems that depend on it. Their work covers enormous power grids that span entire countries, as well as the tiny circuits packed inside a smartphone. The field emerged in the late 19th century, growing alongside the spread of electric power, the telegraph, and later the telephone, when electricity went from a scientific curiosity to the backbone of modern life in just a few decades. Electrical engineers tend to work at 2 very different scales. Some design and manage the massive infrastructure that delivers power from plants to homes and cities, dealing with high voltages and the constant challenge of keeping supply and demand balanced. Others work at the microscopic level, designing the circuits and chips that make computers, medical devices, and communication systems possible. Because electricity is invisible, fast, and potentially deadly, precision and safety are central to everything an electrical engineer does. A single miscalculation can mean a blackout for millions of people, or a device that overheats and fails. As the world shifts toward renewable energy and electric transportation, electrical engineers have become some of the most in-demand professionals in the entire field. Environmental engineer. Environmental engineers work to protect both people and nature from pollution and environmental damage. They design systems for clean drinking water, wastewater treatment, air pollution control, recycling, and the safe handling of hazardous waste. The field rose to prominence in the 20th century as rapid industrial growth led to dangerous levels of pollution and serious public health crises, forcing societies to take environmental protection seriously for the first time. Environmental engineers often combine knowledge from civil, chemical, and biological fields, since solving an environmental problem usually requires understanding water, chemistry, and living systems all at once. A typical project might involve designing a treatment plant that makes contaminated water safe to drink, or building a system that filters harmful gases out of factory emissions before they reach the air. Their work sits at the intersection of engineering, science, and public policy, which means they often work closely with governments and communities. As climate change, water shortages, and pollution become some of the defining challenges of this century, environmental engineers have moved from a supporting role to the center of global problem solving. Industrial engineer. Industrial engineers focus on making entire systems and processes more efficient, rather than designing a single machine or structure. They study how people, equipment, materials, information, and time all fit together inside factories, hospitals, airports, and supply chains, then redesign those systems to waste less and produce more. The goal is almost always the same: reduce wasted time, money, and effort while improving quality and safety. The field grew directly out of the early study of factory work and assembly lines in the early 20th century, when pioneers began carefully measuring how long tasks took and how workflows could be improved. Today, an industrial engineer might redesign a hospital so patients move through it faster, reorganize a warehouse so orders ship quicker, or streamline a factory line so fewer defects slip through. Much of the modern job involves analyzing large amounts of data and using it to find bottlenecks and inefficiencies that are not obvious from the outside. Because nearly every organization wants to do more with less, industrial engineers are found in an unusually wide range of industries, from manufacturing and logistics to healthcare and even entertainment. Mechanical engineer. Mechanical engineers work with almost anything that moves. They design engines, machines, tools, and the mechanical systems found in cars, aircraft, factory equipment, and everyday household appliances. It is widely considered one of the broadest engineering disciplines, which means the same training can lead to wildly different careers. One mechanical engineer might spend a year designing a more efficient jet engine, while another works on artificial heart valves or the moving parts inside a washing machine. The field exploded during the Industrial Revolution, when steam engines and powered machinery began replacing human and animal labor on a massive scale, reshaping the entire global economy in just a few generations. At its core, the job is about understanding forces, energy, heat, and motion, then using that understanding to make machines more powerful, more efficient, and more reliable. A mechanical engineer has to think about how parts wear down, how heat builds up, and how a small flaw can lead to total failure over thousands of cycles. Because their work touches nearly every industry, mechanical engineering is often called the most versatile engineering degree, and many engineers in this field move between industries several times over a career. Software engineer. Software engineers design and build the programs and systems that run on computers, phones, and nearly every connected device around us. This includes mobile apps, operating systems, websites, databases, and the hidden code that controls everything from cars to medical equipment. It is one of the youngest engineering fields, growing rapidly only in the second half of the 20th century as computers shifted from rare, room-sized machines into tools found in almost every home and pocket. Unlike most engineering disciplines, software engineering is not about physical materials or moving parts. Instead, it is about logic, structure, and problem solving, building invisible systems that must still be reliable, secure, and able to handle millions of users at once. A core part of the job is managing complexity, because modern software can involve millions of lines of code where a single mistake can crash a system or expose private data. Software engineers also have to plan for the future, since the programs they build often need to be updated and maintained for years. As technology continues to spread into healthcare, finance, transportation, and entertainment, this has become one of the largest and fastest growing engineering fields in the world, and one of the most influential. If you enjoyed this video, make sure to like and subscribe. We have more to cover. See you!